and environmental variables. In this brief presentation, I will describe a little about the introduction, the objective of our study, and the research gap that we found, the objective of our study. And after that, I will share some details about the data method that we use, resulting discussion and conclusion. In the first step, I think the important question is how do outliers occur in pedestrian volume data? Based on reviewing the literature, it shows it occurs based on the measurement inaccuracies or some errors in devices that we collected pedestrian volume data or some destructive events. So to have a better pedestrian studies, we need to address these anomalies and outliers with the methods. And after we replace these anomalies and outliers as a missing value, we need to use some imputation techniques to address this missing data. So the study objective of this study is examine methods for detecting and imputing anomalies in pedestrian data. And in this study, we consider some epidemiological and environmental factors, and we call this EPI-N variables, like COVID-19, air quality index, and etc. So, and as a part of literature gap, we found limited studies that focused on using some novelty or new methods to detecting anomalies, and after that, imputation missing value. So I think in this study, we filled this gap in this area. As a data source for this study, we utilized a pedestrian volume data that estimated from pedestrian signal activations, or I should say, we used a push button data for estimate pedestrian volume data. And after that, we worked on this pedestrian volume data to detect anomalies or imputing missing values. The data that we used is for traffic signals in Utah from 2018 to 2022. In other parts, as a data source, we use EPI-N variables. As I've said before, these data consist some temperature or precipitation, air quality index, AQI, or COVID-19 case in Utah. These are samples of the data source that we use in our research works. These are the AQI categories in Utah in 5 categories. It's a sample of daily high and low temperature around the specific traffic signals. And this plot shows the daily COVID-19 cases in 4 phases. And also we use a built environment variables for supplementary analysis and discussion parts of our research work. After we detected anomalies and imputed missing values, we use these built environment variables for supplementary analysis. This figure shows the methodology and framework of research works, and I have to confirm again, we used pedestrian volume data that estimated from the push button data. So for anomaly detection, we applied autoregression analysis to identify period influenced by EPI-N variables. And after that, to evaluate the effectiveness of our anomaly detection methods, we injected synthetic outliers in our data sets. And after that, we applied some anomaly detection techniques like statistical methods like data score, machine learning method, like iForest or DVS scan, or deep learning methods like GRU or LSTM. And you can see in this plot a synthetic outlier injection that we used. The blue lines are data with injected outliers. The orange spot shows synthetic outliers, and the red one is original data for specific traffic signals, and this plot shows the time series data. And the black lines shows the period that we identified influenced by EPM variables. In the next part of our study, we used imputation strategy. We categorize missing value. We categorize our data based on the missing value patterns in 3 groups: random point, complete, and hybrid missing value patterns. And we apply some machine learning and deep learning methods on that. And we evaluated our method with using some metrics like accuracy, precision, recall, F1 scores for anomaly detection, and MAE and RMSE for imputation methods. If I want a quick jump to the result and discussion, I should say, after reviewing different methods, we found the DBS scan method demonstrate the highest accuracy for identifying anomalies in our data set. And you can see it has accuracy about 87% and F1 score about 0.83. And the plot shows the clean pedestrian volume data because we replaced anomalies with the missing values. And in the next part, we applied some imputation methods for imputing missing values. And the results of imputation methods shows the random forest works better on the random point missing values patterns. LSTM works better on the complete missing value pattern, and GRU showed the better performance on the hybrid missing value patterns. And in this slide, you can see the sample of how we applied imputation methods on our data set. The first one is applying random forest methods on random point missing value. And the second one is applying GRU method on hybrid missing value. You can see the complete pattern or random pattern in this time series data. And third one is the pattern of the complete missing value that we imputed missing value using the LSTM method. And the results and discussion we found when we used the built environment for further or supplementary analysis, we found the temperature had a significantly influence on pedestrian volume, specifically during cooler and wetter months. And we found in areas with the higher number of transit stops, impact of temperature is less significant. And the COVID-19 pandemic in phase 3 had a substantial influence, June 2021 to February 2022. And in densely populated urban areas with a higher commercial density and with a higher schools and with a higher places of worship, COVID-19 had a significant effects on pedestrian volume data. And I think I reached 9 minutes for the presentation. And you can find the GitHub repository of this work and the whole codes of applying imputation methods or anomaly detection with a scan this QR code or TRB version of the manuscript with this scan of this QR code. And I think until the next month, because this research work accepted for the TRR journal, and you can find the final or revised version of this paper on TRR until the next month. Thank you.
Thank you, Amir. That's great stuff. I will also encourage you to, in addition to that QR code, to just paste the link into the chat also in case people have trouble with the QR. That'd be helpful. Thank you.
Sure.
And I will remind everybody, we're going to have 2 more presentations, and then feel free to add some questions into the chat if you have them for that we'll address afterwards. Or also when we get to the conversational part, you can just press the raise hand button and we'll have conversation and live questions. I'm going to turn it over to, I believe, Jonah. Jonah, I'm going to say your last name and get it wrong. So Chiarenza, am I right?
Nailed it.
I'm nailed. I think that's a close enough, probably. Anyways, Jonah from Volpe, I'm gonna have him turn over to talk about his paper. So Jonah, you can go ahead and take the screen share, and the floor is yours.
Great. Everything coming through?
Yeah, you're sounding good, and
Okay.
I can see your screen.
Great. So I'm going to do a lightning round of this presentation we gave at TRB. Thanks again for selecting this paper for presentation. We also are selected for a TRR publication, and that should be imminent. So we can provide the committee with an update once we get that. But this research was already actually published just by Federal Highway on a website. That the QR code for that is coming up, and I'll also put it in the chat once I stop presenting. So the goal of this study was to look at existing information about our understanding of e-bikes in a public lands environment. E-bikes continue to grow in popularity all over the world, and their use is expanding in public lands. What we mean by public lands are like, the National Park Service, the National Forest Service, the Bureau of Land Management at a federal scale, as well as state and local parks and recreation facilities. So, linear paths, multi-use paths, parks and gardens and things like that. And so understanding how e-bikes work and what their benefits are and what their drawbacks might be, and how to potentially mitigate them or apply policies to maximize benefit and minimize impact is relatively poorly understood. And so we set out to establish a framework for organizing what was known, and then a roadmap for directing future research to complete that research and then document it. And so throughout this, I'd like you to be thinking about like, what research projects could I dream up next to help complete and fill some of these gaps. So we did a big literature review, as I said, based on a lot of feedback we got from technical review group and stakeholders representing not just the bicycling public, but all kinds of public lands users. We developed a list of 60 research questions that fit into these 4 categories: ecological, cultural, historical resources, safety factors, social factors, and then the processes for managing e-bikes in or on public lands. The results, as I mentioned, were that many of these categories of information that people were curious about that came out of that stakeholder and technical review group brainstorming are not known, right? We had some areas of significant, but they were minimal of significant information, and they were minimal. The majority had partial or no information to kind of answer that these questions in a scientific way. And so we set about on a second part of this project to deploy a field study using partners from Volpe, from our human factors group, from our GIS engineering group, from our data science group, and from our AI and machine learning group. The project took place on the Minuteman National Historical Park here in Massachusetts. We asked participants to come out and ride this 8-mile round trip. This is a video from participants that I'll show. We attached GoPros to their bikes. So we had folks come out, ride their own bikes. They had to be able to get to this location. The idea was to try to get as good as possible examples of people who would typically ride their own bike that they're familiar with on this trail that they're also familiar with, to try to get typical results of that kind of the public that would appear on that facility on a regular basis. And then we were able to take that GoPro data, and because it's a 360-degree video, as you're seeing here, we can pan around in the video and see what the rider sees, and we can see the environment around the rider in a dynamic way, which is really neat. We were able to also take speed data off of the cameras. Every frame of video has a lat long and it has speed. And so we can use that to study behavior. One of the things that we were able to do to kind of zoom in and not just get averages or sort of general, like what was the average speed across the whole length of the trail, was zoom in on specific subsets or sections of the trail, looking at areas where speed and behavior would have an increased impact on the social experience and the equity not equity, what's the word I'm looking for? The politeness. I'll think of it. Tony, jump in if you know what I'm trying to say here. Or safety factors, right? Speed having a factor on your ability to slow down and avoid crashes or conflicts. And so places like blind turns, constrained and narrow sections of the trail, places where the trail had a hazard in it, rock outcropping or roots, places where the trail joined other trails or crossed vehicle pathways. And then and we also were able to look at uphill and downhill sections of the trail just based on our knowledge of the proximity of the topography. So what we did was we identified all these sections, and then we created these polygons sporadically along the trail that periodically along the trail. We were able to then see when a participant passed through one of those polygons, their GPS pings landed in that polygon. We were able to know, okay, we can code that as blind turn data, or constrained narrow section data, or vehicle roadway crossing data. And as a result, we were able to take 27 participants and get a lot more data points than we would have if we just sort of looked at 27 data points of like average speed across the whole corridor. Here's a zoom in looking at what that looks like. And some of them would overlap, right? Because a data point might be sort of part of a blind turn and a vehicle crossing point. We learned some lessons. So the GoPros that we were using, some of them seemed to need to be powered on for a little while to get a GPS lock. It probably had to do with where the satellites were, tree cover, maybe other factors. And so we had some errant data, which meant we didn't get to get as much data as we might have. That was a good lesson learned. We had some people allegedly riding their bikes in the middle of the Atlantic Ocean, so we knew something was off there. But we did end up getting 27 out of the target 40 participants worth of good data. Here's the breakdown of male and female riders and the types of bikes they were riding. It's a little definition of classes in the upper right, if you're not familiar with those. And then this is kind of the key slide, I think, if you wanted to sum this up in one slide, and it is showing both the average speed by our two cohorts of e-bike and conventional bike riders, but also the distribution of speeds and the max and min speeds across those cohorts. And so the key takeaway here is that, yes, on average, e-bike riders are riding faster in all of these categories, but the overlap in speeds and the high and low ends of speeds are very consistent. And so, the average is only telling you one part of the story. We looked at it in a couple of different ways to kind of see. One of our litmus tests was like, we expect uphill segments to have the greatest differentiation, where the power of the motor is going to allow e-bike riders to maintain a higher speed on average than it is for conventional bike riders. In the downhill segments, there's very little advantage to having a motor. And we saw, consistent with that there would be a greater overlap in speed. So that was good, demonstrated to us that the rest of the insights we were making were probably correct. This is all of those areas of concern, not the uphill and downhill sections, but all of the areas where we wanted to study, potential conflict overlapped. And you can see again, the overlap, the delta is like 1 to 2 miles an hour on average, but the distribution is quite great. And the high and low ends, there's speeds present in the buckets, even at the extremes on both sides for both e-bike and conventional bike riders. We did a regression analysis on these data to see, what pops out as the most prevalent predictor of speed. And we saw that bike type, whether it was electric or not, looked like it added about 2.2 miles an hour in speed increase. But male sex indicated a 2.5 mile an hour increase in speed. And so thinking back to the purpose of this, to advise public land management agencies on how to just make decisions about where to allow or prohibit and where to enforce or sort of disregard enforcement of any rules around e-bikes and conventional bikes on their lands. What they really should do is just prevent males from riding their bikes on public lands, because that's the thing that's most likely to result in a higher speed, to result in conflicts. We saw also that, I think for the interest of time, I'll just sort of zoom ahead. So that was our speed behavior that I was just showing. Another thing that we did was we applied a machine learning algorithm off the shelf that could detect typical objects like bicycles and pedestrians. I think at one point you can see that it detects this person's backpack. And by doing so, we were able to create dynamic polygons, if you will, along the route that occurred whenever a rider, a participant in our study, was passing another trail user. And we could identify whether they were riding a bike or walking. And we could then look at and see what was the speed on the approach to that passing activity and at the point of that passing activity, and see if people were slowing down as they were approaching and then overtaking other riders or walkers on the trail. And indeed, we saw consistently that e-bike and conventional bike riders both reduce speed while passing. However, you can see, again, looking at just averages here, the electric bike riders were riding faster before they passed, and even faster, they were also riding faster when they passed than conventional bike riders were. But the point here is that people are taking precautionary measures and slowing down on their approach to passing others on average, which suggests that people are taking the kind of right types of behaviors that we would want to see for safety. Another thing we were able to do was look at the video and actually study manually, although there might be a way to automate this, whether people were turning their head and glancing towards potential conflicts. And we saw that at locations of road or trail crossings, at road crossings, there was more sort of consistent glancing as would be expected towards potential conflicts of oncoming vehicles. And at trail crossings, we saw conventional bike riders glancing more frequently than electric bike riders. I've already gone through this, so I'll skip ahead. These are our conclusions. It's in the paper. The next steps are, there's still many questions in that desk review to answer. We implore the research community to look at our original lit review and look at those questions and identify questions that you might find of interest to study, and go out there and try to help us populate the research to help answer these questions. We are ourselves undertaking another field study that's going to focus on e-mountain bikes. We're doing that in partnership with the Pennsylvania Department of Conservation and Natural Resources on 2 state forests in Pennsylvania. And we're going to work with the Bureau of Land Management in Moab and the Slick Rock area in southern Utah later this summer, getting some additional studies out to look at some of the same things, speed and yielding behavior and glance behavior, but also potentially looking at erosion, and then also looking at impacts of trail design on behavior. There's an opportunity to sort of modify the trails, at least in Pennsylvania, over the course of the summer because of a contract that they have to do some trail maintenance. So we'll be able to see, are there procedures or administrative interventions that communities that administer natural surface trail networks could use to help allow e-bikes to sort of coexist in a way that is, again, maximizing benefit and access while minimizing those negative drawbacks of their participation in the difference. So thank you very much.
Thank you, Jonah. And yeah, that's fascinating. There's so much exploding so quick with e-bikes. Great stuff. Before I have Greg give a quick overview of our workshop, there are a couple questions in the chat box. I'll just throw. Liz had 2 questions for you, Jonah. The first one, wondering if you were able to get trail condition data, and the second one, which I think you might have mentioned there, is she's interested in if there were classification schemes for the e-bikes beyond just conventional and electric.
We did not look closely at differences in the classes, like class 1 versus 2 versus 3. because it's a relatively small population of riders. So that's something I think a larger study or a study that had a higher volume, there's just not going to be like good statistical information in like a few class 1 versus class 2 versus class 3 riders. So for that purposes, we grouped them all together. That was the second question. What was the first question?
The first question was if you had collected data on the trail conditions.
So we didn't look at trail condition, like, using accelerometer data or visual inspection data from the cameras. It's a rough, like, gravel and dirt trail. So the only sort of condition assessment we did was when we set out originally to kind of identify the areas that we thought speed might have more of a factor, that if we wanted to zoom in on with those polygons to study.
Thanks. And then I see, thanks, Patrick Singham. I see that Will Rogers III had a question about working with agencies for the signal data, and you can reference the chat box for his response to that. And then Avipsa, I hope I'm not pronouncing your name wrong. Roy has 3 comments I'll read out, and I'll invite her to turn on her microphone if she wants to clarify. First, I think the sample size is too low for the bike study to deduce any behavioral implications. Also, for the gender types, it would be nice to make it more representative. Second, regarding the AI tech part, it's cool but very intrusive and mostly applicable to bike groups, bike competitions, but not tracking bicyclists at intersections virtually through cameras. It's just creepy. Speed limit could be a good addition to the study on top of the slope. And I don't know, Jonah, and I'll invite Avipsa, with the apologies if I'm mispronouncing her name, to add anything to that. And Jonah, if you wanted to respond.
Yeah, I had this discussion with our human factors group, like, God, is this really representative? And they're like, no, it's a human factor study. That's how we do it. We get people to come sit in a lab and like look at a simulator, and we like get as many people as we can who are most representative of the population we want to study. But it's not like a statistical analysis of the entire cycling community. That's like really hard to do. Our hope is to get much higher numbers in partnership with a couple of universities, including Patrick's in Utah this summer. And that'll hopefully allow us to have a human factor study that still is like more representative. We asked people their gender or sex, and they told us male or female. In this particular study, we didn't get anybody that wanted to be identified or use a non-binary or other category of gender. But had they, we would have included that. And I think perhaps with a larger sample, we will. I think that's a great point. Yeah, the camera tech being creepy is 100% true. I think it's cool and creepy. And one of the things that as a federal agency we are very careful about is maintaining PII, which is why you saw when I panned the videos, I didn't show their heads. The head you saw was my head and other participants that had signed off on being part of the study. So yeah, I agree that it's creepy, but as long as we can have sort of system on a chip processing in the future, particularly in intersection cameras and stuff like that, where counts are happening, but none of the raw visual data, except for calibration, is going to a database to be reviewed. I think we can have the good without the bad.
Yeah. I think, and by the way, I apologize for not throwing you your lifeline on the word, but if you looked in the chat, I think Greg did come up with the trail etiquette, probably the word.
Etiquette.
It's a nail on the head. You always the better vocabulary. With that, I'll transition to Greg to give an overview of the TRB workshop before we turn things over to Sarisha to talk us through questions and RNS statements. Greg, go ahead.
Stop. Get the wrong. So what I'm going to try to give a quick overview of our accomplishments at the TRB workshop for those who are unable to attend. And right now my machine is freezing up. So sorry about this. Go with this. So in January, we had a meeting in response to needs that many of our members were doing bike counting and analysis of bicyclist behavior, about the need to do more with different types of big data, connected data, crowdsourced data, so that we can address problems that we've not been able to do in the past because of financial resource and other limitations to traditional accounting programs. We had 100, it was a 3-hour workshop. We had 20 volunteers involved with presenting and organizing and helping to coordinate activities at the workshop, and more than 120 people show. It was a sort of an overflow crowd, and we were quite pleased. And we think what it does is it shows the importance of the types of research you just saw. So for example, the work that Amir and Patrick did on use of traffic signal actuations is an example of a way that we can solve the problem, one of the problems associated with the high costs of trying to do monitoring at different locations. So but what we found at the workshop was that people are extremely interested in this, in part because of the promise it holds, and in part because of the challenges traditional counting programs have. And they raised a lot of issues. So what I'm going to do is try to give you an overview of just a couple issues that they shared that underscore the importance of what we've just seen by researchers. And then we'll move to Sirisha, who will talk about what are the key research needs we need to advance our profession forward. At the workshop, Sean Turner from TTI talked about different types of non-motorized data, and he raised questions of how good is good enough. Phil Asley, also from TTI, spoke about the challenges they faced in using data fusion or data integration techniques in some cases. And then Sirisha and Mintu Maya presented work they've done to combine, for example, traditional counts with Strava fitness data or streetlight data, the indices that come from streetlight. So that was, they provided an example of, I think, what is path-breaking research to move us forward in this domain. And then we had 4 people. We always try to maintain a collaboration between researchers and practitioners. We had Steve Jesberger from FHWA, and then 3 state DOT individuals, Peter Olms, Josh Roll, and Brian Wood, give their perspectives on where their states are. So what we try to do is both think about the resource frontier and the challenges we have day-to-day practice in implementing these things now. What we found, there were comments that were, I think, really instructive in terms of thinking about how we might propose new research studies to move the field forward. People raise a number of substantive issues, like how do we collect, analyze, and validate these new types of non-motorized data? And you just saw a good example of that in one of our research studies that will be, as they said, will be in TRR soon. But we talked about a lot of different types of data that have potential to enhance our understanding of pedestrian and bicyclist behaviors. Traditional automated counts, fitness apps, fleet station and trajectory data, for example, bike share, video image data that people can use. We can use traffic signal actuations and various types of location-based services data, including things like credit card transactions. So there's a set of challenges that we face, and the question is, how can we put this together to get replicable, valid, sustainable data production systems to inform the work we need to do? At the same time people were doing that, raising these issues, they raised other issues. For example, what should be the geographic scope of our work and the focus of counts? Do we hold networks, or should we focus initially on high priority intersections? What are the interpretation of use of counts? And what are guidance and translation for practice? And what we found was sort of 2 tracks, which is, I think, a strength of TRB. There were people at the forefront of the research, like you've just seen with the epi and environmental variables as a way to understand and use traffic actuations to find pedestrian volumes in urban environments. And at the same time, there were people saying, you know, I've just been hired my state DOT. My job is to get a new monitoring program off to the floor. Where do I begin? And so I think we have both those participants in our field, and we need to keep track of both those. So people came up with a set of priorities at that workshop, and a subsequent where the Bike and Peds data subcommittee the Highway Traffic Monitoring Committee and the Bicycle and Pedestrian Committees, talking about how do we help practitioners choose from these new technologies that are available, and then how can we give them guidance on integrating those with other types. And so we said both these could be research needs statements. And so we have a subcommittee of our subcommittee, if that's not redundant or something. But so Martin Gutenplan, Nathan Hicks, Jordy Honey Rose, Sarisha, myself have met once to begin to think about how we might be put together different types of RNSs in the area of data fusion and data integration. What we are the objectives that are working in the materials we've reviewed. Let's sort of look at how can we document state-of-the-art promise and perils of data integration and fusion methods. How can we assess the validity of micromobility traffic volume estimates? How can we develop guidance for practitioners for choosing among different types of connected data? And how can we provide guidance on the validity of volume estimates needed for different applications? And one of the things that's hovering over us all the time is this question of how good is good enough? How accurate, how valid do our numbers need to be? So our next step, and this is where if you're interested in these types of ideas and fostering research, we welcome you to join our subcommittee. And we'll be meeting again. We're going to review a working draft. In May, we hope to get that to the Bike and Ped Data Subcommittee so other members can review, and then in June, a draft to AASHTO. So what came out of the workshop and all the good work that, for example, the two presentations we've had today is how do we foster more of that? And Sarisha has a wealth of experience in the RNSs. And so she's going to take it now and talk about the process in a little bit greater detail. Sarisha?
Yeah, thanks, Greg. I'm just going to try and share my screen here. Okay, are you able to see my screen?
Yep, we got it.
Perfect. I'll just make it full screen. All right. So as Greg said, I lead the subcommittee, research subcommittee of the subcommittee. So basically what we are trying to do is look at what is being done in bicycle and pedestrian data research, and then develop research needs statements to sort of foster more research into topics that are of relevance to both researchers and practitioners. We also find organizations that can fund and conduct these research. So this could be organizations like the National Cooperative Highway Research Program, NCHRP, and it does that through both the synthesis program as well as full statements. We also submit statements to behavioral traffic research needs, which is basically looking at behavioral research similar to what Jonah presented earlier. And then we also promote these statements to these organizations and put them up in the RNS database. And so these are also available to university transportation centers for students who are looking for, topics for projects and thesis and dissertation options. And then we also track any previous and ongoing and upcoming research in the RNS database. So any of the projects that have been funded through the subcommittee or other committees at TRB that have a pedestrian or bicycle data component, we keep track of it. We request updates from the PIs of those projects so that we are informed and also can contribute to the research by reviewing and sharing it as well. So as I mentioned, our funding sources are generally we've submitted to these three programs. The Behavioral Traffic Safety Cooperative Research Program, the deadline this year, they changed it to January 5th. It used to be generally the middle of February. Then the NCHRP synthesis, which are basically smaller projects that basically are looking for synthesizing information on research that's already been conducted. And so the deadline for those topics is February 16, middle of February generally. And then the big NCHRP projects, which actually perform original research and this is of interest to the state DOTs because they are the main funders of this program. The deadline for that is typically early November. So as a subcommittee, we are not allowed to directly submit any of the problem statements that we develop to NCHRP. Instead, we have to work through the AASHTO committees or any of our DOT partners or FHWA. And those are the only 3 entities that can submit NCHRP statements. We, over the past few years, have been pretty active in developing some research needs statements. Not all of these oftentimes get funded. And so when a statement is written up and it does not get funded, typically we will take the feedback that we have received and then try to make it stronger and resubmit for next time. So these are a couple of statements that we had written up a couple years ago. The first one is looking at methods for designing a statistically robust network of active transportation count stations. This came out of the fact that when we are looking at data for research, most of the data from counters are, and especially the permanent counters, are at locations which have high volumes. And this is done intentionally, right? Because these counters are often purchased through grants, and so they're put in places where they can show stakeholders the importance of counting. And because these can cost, a good amount of money, and resources are few, we've typically placed these at high volume locations so people can see the importance of the counts, and then we can get more money for buying additional counters. But what that has led to is a network of these count stations only at high volume locations. And if we want to basically estimate volumes on the network, then we have a lot of gaps. We are not counting our low volume locations at all. And so this research statement is basically looking at devising a method using statistics for designing this framework for active transportation count station location. The second statement that we had developed was to develop standard protocols for QA/QC. There are a few agencies which do have automated QA/QC checks, and these are the ones that have online archives to store the data. But we've noticed that the QA/QC checks can differ from agency to agency, so there's no standardization of these checks. Also, most of our checks so far have been, again, catered to these high volume locations. And so the checks that we've used there may not be directly applicable to low volume locations. And so there is some research needed in there. Validation and calibration is a huge consideration, especially if you want to maintain your count program and have accurate data coming out of the counters. A lot of agencies have set up these counters and then forgotten about them. So a lot of times the batteries run out and nobody goes in and changes those batteries, or the counter itself may drift over time. So there is regular maintenance that is needed to both calibrate the counter to make sure that the data coming out is accurate, and also validation needs to be performed in an ongoing manner. So there is some research that is needed for all of these issues related to data quality itself. And so, as I said, both of these statements have been written up. And so we're looking for people to sort of review these again and suggest some changes so that we could, maybe resubmit this for funding consideration. Over the last year, one of our parent committees, the Travel Monitoring Committee, ACP 70, undertook this the development of the e-circular. And so the objective of the e-circular was to basically talk about the advances in travel monitoring, and it looks at what the state of the practice is, as well as what are the gaps that currently exist, and proposes some research needs. So our committee, our subcommittee, the Bicycle and Pedestrian Data Subcommittee, created their own e-circular about 10 years ago in 2014, and that's available on the web. But this time around, we decided that we want to be part of the overall Travel Monitoring Committee's e-circular, just to highlight the fact that bicyclists and pedestrians are also part of travel and traffic, and so we need to be included in there. So as a part of this exercise, various members of our subcommittee contributed to the chapter focused on bicycle and pedestrian data and travel monitoring advances over the last decade. And so we came up with about 7 research needs that are listed in here. The first one is on the assessment of accuracy and usability of emerging technologies for bicycle and pedestrian detection and counting. So recently we've seen the emergence of AI. Jonah showed that in his presentation, and video cameras have gotten pretty sophisticated, and there've been other, detection equipment like radar and LiDAR and, others that are emerging. And so we need a study to understand what are the accuracy of, these different devices, and where should these be used? Because every device will have, its strengths and disadvantages. And so there's some guidance needed on all of these emerging devices. The second statement relates, or research need relates to the use of the micromobility count data. So the TMG 2022, instead of using bicycle and pedestrian data, uses micromobility. So it's encompassing e-bikes and scooters and all of these other devices or modes that have sort of emerged. And one of the things that we've been hearing from practitioners like across agencies are that, some of the agencies have these count archives, but a lot of people don't know that these archives exist, or they don't know how to use the count data. The count data are generally used for a number of different purposes. For monitoring trends, you can use it for safety analysis because it gives you the exposure. You can also use it for planning and designing new infrastructure, and a host of other applications. But there needs to be some documentation about how different agencies are using it, or what could be done, so in form of case studies, so others can see the the advantage of collecting counts, storing counts, and then use these for other applications. So the third one is designing a statistically based continuous count program. We already have the statement for that. I just talked about it some time ago, so I'm not going to spend more time on it. Enhancement and expansion of short duration count programs was another research need that emerged. So states have varying types of short duration, or I think the correct term now is short term count programs. Some of them, count data for less than 24 hours. Others count for 48 to 72 hours. The findings or recommendations from research is that because bicycle impression data or travel is so variable, that we should at least count for 7 days. And then the TMG, the latest version recommends that you count for 2 weeks. And so when you're counting for 2 weeks, there is some research needed again to see how do you select the count sites for the short-term counts, and how do these, supplement your permanent count sites when you again want to count across the network, and then some other considerations. Another topic that came up was creation and integration of relevant non-motorized data sets. So as I mentioned, a few states have archives for non-motorized count data, but when you want to, work with this data, a lot of times you also need other data sets like your infrastructure data, your crash data, and maybe a few other things. And so how do we integrate all these relevant data sets together, so which would then enable us to perform, analysis. And then validation and calibration procedures. I talked about integration of emerging data with volume data. That's the one that Greg talked about. So basically looking at how do we take these crowdsourced data sources and then integrate that with our traditional count data to produce volume estimates. So we have a working group for that to develop the statements. If anyone's interested, please let us know. And then finally, automated data quality checks, which I also sort of talked about earlier, to enhance the quality of the data. So I'm going to stop there. I guess we don't have too much time, maybe a couple minutes, but if going to open it up if anyone has any thoughts or comments or questions, or if you're interested in contributing to any of these research needs, please let us know.
Yeah, we are right up against the top of the hour here, so I will encourage folks, if you do have questions. I know that the chat box has been pretty busy here, and one thing, Srish, I know that's one of the things also, if folks are interested in some of these ideas or have ideas, we'd love to have an opportunity to follow up, and it might even be useful, Sarisha, for you to put your contact information in as a point of contact, your email maybe in the chat so folks can get to that. I did see a few questions. I'm trying to read through the questions that have been answered and not. Certainly there was, I think, well, Jonah had one I don't know we've answered in this, and this I think I know the answer to, but does anyone know about ways to differentiate between e-bikes and conventional bikes and count data? And to my knowledge, there is not a solution to this. I don't know if anybody that's on the panel or participating right now has an input or thought on that.
So we recently manually, transcribed some video data for looking at conflicts between bicyclists and transit riders on those new, platforms that our transit agency is using, where the bike lane comes up and is level with the waiting area where transit riders are waiting to board or alight the bus. And there, our students were able to record whether it was an e-bike or a regular bike by looking, through the video data and trying to look at the battery. But I'm not sure if, yeah, I don't think that the automated methods can do that yet, but maybe we'll have some algorithms pretty soon.
It kind of connects in with possibly another research need statement. I would I would be interested to say, well, we are right at the top of the hour. I know there's other questions. I thank everybody for their time. I did want to let you know we have June and July scheduled. You see that these are tentative. We're still fleshing out some things for the series, so stay tuned for announcements. And then also watch. There were a lot of links for each of the papers and presentations in the chat box if you didn't get those. And then I also put in a link for those of you who really want to get more out of this. Want to remind you that the National Travel Monitoring Exposition and Conference, or is affectionately known as NatMec, is coming up quickly here in June in Boise, Idaho. And I did highlight on this screen, there is a lot of content that is of interest to our group, particularly in the track 1 there. So there's a link there at the bottom, a link in the screen for those who are interested. I know the early bird registration is over, but it's one of those conferences that's not extremely expensive. So if you're interested, take a look at that. With that, I will just, I guess, thank everybody. I know we're at the top of the hour. Appreciate your time and stay tuned. We look forward to seeing you at a future conversation.
Thank you, Tony, for hosting us.
Thanks, Greg, for setting it up.
Thank you.
Thank you.
And Greg, you will, we might comb through the chat and send something out. I know there was a lot of content in there. We were we got a little shortchanged on trying to get more discussion that we would like, but good lesson for the future.
I'll do that. Thanks again, everyone. I'll go ahead and shut down now.
All right,
Bye-bye.
thanks, Greg.